Hi guys, Mr. T again. Today we're going to talk about finding complex solutions of quadratic equations and then using the quadratic formula specifically. Okay, so this is out of our current textbook section 3 of module 3, and we're just looking at the part of it where we're solving it using quadratic formula. Now, why do we need quadratic formula? So let's back up just a little bit and see what's going on here. What they have here to kind of show us the need for quadratic formula is 3 different quadratic equations. Okay, and what they did is they brought the constants to the other side, and then you notice that all of these, this side over here is the same, and then all the constants are different. Okay, and then they broke them up here, and then you see it on the graph. You see it's the same parabola every time, but the line changes. And the point there being is that when for this first equation it crosses twice, so there are two real solutions, and we have means for working that out with our graphing calculator in other ways. And then if it just touches once, there's one real solution. Okay, but what happens when they don't touch at all? Well, then we can't solve by graphing. It causes all kinds of problems. And so, but that doesn't mean there aren't solutions. We have imaginary solutions, and we've talked about where imaginary numbers come from, and that's such a thing. So there's no real solutions. However, there are two imaginary solutions. And so that's where quadratic formula comes in real handy, especially. It works for everything, but it's real handy for imaginary solutions. Like the graph, it's real easy to do with our nice fancy graphing calculators, but sometimes you just got to use the old-fashioned way. Okay, so let's jump up to our next thing here. And so here it is. Here is the quadratic formula. And what I always ask people to do, and if you're in my class, this is not an option for your homework, is that every single time you go to do the quadratic formula, you are required to write the quadratic formula down. And we have the nice little song that goes with this. It goes with Pop Goes the Weasel. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So let's just Pop Goes the Weasel. And then you can get faster at it. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And then in class, I like to do it several times so it gets it stuck in your head, and maybe it helps you remember. So that's a quadratic formula. You need to have that memorized. So I ask you to write it down every single time. Okay. So there's the quadratic formula. We'll talk about the other things first. So let's talk about our first example. Okay. It's going to be, we're going to use 6x squared minus 5x minus 4 equals 0. Okay. And the first thing it says, we got to write the equation with 0 on one side. This one's already got that under control. Well, the next thing I'm going to ask my students to do is, this is in standard form. I want you to actually write, what does A equal? Okay. I want you to write down A equals B equals C equals. Okay. And I'm going to change colors and write this in. So what does A equal? 6. B equals negative 5. C equals negative 4. And I call this the caveman method because be a smart caveman, mind you. But it's still just so simple that even a caveman can do it. A smart caveman, but it's a caveman. Caveman can sing the song. X equal negative b plus or minus square root ha 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 b squared minus 4ac all over 2a ha ha ha. Even a caveman can sing that song, right? Okay, and then a smart caveman would make sure it's equal to 0 and go, oh, first letter in front, go over here with A, all right, ha, and then the next letter in front, go with B, yes, next number, excuse me, and go negative 4, so A, B, C, got it. Caveman can do that. Smart caveman, but a caveman, so simple, very little brain power. Moving on here, okay? Okay, the next thing I'm going to ask them to do is I want you to rewrite the entire equation with a bunch of boxes. With just a bunch of boxes. Okay, now we're going to eventually put a parentheses around there if you want to, but I already had this one already set up, but I haven't just put the boxes themselves. Okay, and then what I want you to do next is I want you to put the numbers in. So well, caveman says, okay, box. Well, what goes in box? B. Where's B? Where's B? Oh, B, there's -5. So we put -5 right there. Ha ha ha. -5. Okay, what? Oh, another box. What goes there? B. Okay, what is B? -5. Oh, yes, B right there. -5. Ha ha ha. I'm smart, caveman. I can do that. Box is here. A go there. What's A equals 6? 6. Yes, 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 yes. Yes. Oh, another box. I like putting things in boxes. I'm so good at that. I am. See, that's a C. It's a little sideways curvy thing. Where's another one of those? Oh, there's another one right there. It's got a little dash and an angle thing. And okay, so a dash and an angle thing and a straight line. Got it. Oh, one more box. What's that? And get roundy straight line thing. Okay, where's one of those? Okay, and it's got that little swirly deal, right? Yes. So yeah, it's kind of silly. It's ridiculous, right? But what my point is, there should be no brain power here. Just walk through this process. Okay. Now, one thing that this doesn't have, I need to add back in, is the next set of parentheses. So if you've done this and you've filled in the boxes, and I ask them to do the fill in the boxes in another color, that way I know that you didn't fill them in at the same time. Because if you fill in the numbers at the same time you draw the boxes, you ruin it. You completely ruin the thing that is going to be helpful to you. Because you see this right here? See this? The tendency for people to do is if they because of the negative sitting here, they just put a 5 there instead of -5. It happens. People who know better still do it anyway. Okay. And so if you just take all that thinking out of it and just stick the numbers in the boxes, you have a much better shot at getting this right. So we have a -5 here. So what's a minus a negative? Well, that's going to be a +5 right there. Okay. So this is generic. It had the negative sitting there still. Okay. Now this one says -2, but again, this is a generic, so I don't know if it's going to turn out that way or not. We'll find out in just a second. Okay. So what am I going to do next? Again, I'm trying to go low brain power. Okay. So what I'm going to do is I'm going to take this stuff right here and put it in my calculator. You notice what I'm not going to put in? Not the square root. No, not the square root. Just the stuff in the highlighter with the parentheses exactly like you see it. If you get all crazy smart, like you think you're a high schooler or something, you're going to mess this up. Think caveman. Caveman hit buttons. Okay. All right. So we got this. So grab my calculator and I'm going to go open parentheses. What's it say? What's it say in the parentheses? It says -5, close, square, right? -4, open, 6, close, open, -4, close, enter, 121. Okay. And so that's it. We're going to go over here and go plug it back in. So get my guy here. So we got positive 121. Easy enough. Oh, and then this is going to be not 14, but 12, right? 12. Okay. Obviously, I copied it from something else and I forgot to change those parts. So that's what we have. So to this point, a smart caveman could do this. Don't mess it up by trying to get all fancy. If you'll just walk through the process, it takes you a couple extra seconds to do it, but most of the errors with quadratic formula come from not doing these steps correctly. Most of them. Okay. And here's the good news. At this point, you could put that in and turn it into a decimal. And if you're doing a multiple choice test, you could take all your answers and turn them to decimals and then compare. Now, we don't want to be just doing that. Now, that's just copping out and making it too easy. So let's do this right here. what does this mean? So at this point, it's where we take off our caveman hat and we put on a smart, math student hat. Okay, this is where thinking starts. So we got our positive 5. All right, 5 right here. The plus or minus, got it. Square root of 121. Hey, that's a perfect square. So what's the square root of 121? Plain old 11 over 12. Okay, so what does this actually mean? This means 5 plus 11 over 12, right? And it means 5 minus 11 over 12. So 5 plus 11 over 12, that's going to equal 16 over 12, also known as 8 over 6, which is 4 over 3. Okay, so finally got it all the way down. That's fine. And then what's this guy here going to be equal to? So let's see what's going on. 5 minus 11, well, that's negative 6 over 12. And then that would equal negative 1/2. So if we were to graph these, that's what we cross the x-axis at negative 1/2 on the x-axis and positive 4/3. Be 1 1/3 there, right? So that's one way using the caveman method. And that's generally the process right there. Okay, I'm going to do a couple more that have some different kind of scenarios, but these first few steps are always the same. Okay, and until you get to this step right here, there's no real brain power going on. Very, very low brain power. Don't try to short circuit the process and then mess up the things that really help you out here. When people will walk through it in this fashion, it's kind of annoying, some of the extra steps you're taking, but it will get rid of a lot of the biggest and most egregious errors that are made with quadratic formula. Okay, at least make your errors right here. Okay, if you're going to make an error, make them down here. Don't make them there. Okay, let's look at a couple more real quick. Well, I don't know how quick we can be, but we're going to do our best to get them quick as we can. All right, come on, hit the right button there. All right, here we go. So our next equation, it says x squared plus 8x plus 12 equals 2x. Now, so this is our next quadratic equation. First thing we need to do is what? We got to make sure this thing is equal to 0. So we're going to subtract 2x on both sides of the equal sign, and I only can add and subtract like terms, right? So put that underneath the other side there. All right, so now x squared plus 6x plus 12 equals 0. Now we're in business. We can get that started. Got that done. Now we're going to write our quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Writing that down helps you memorize it. Okay? The next thing we're going to do is we're going to write a equals b equals c equals. Then we're going to come over here. What does a equal? Well, there's a 1 right here, right? So 1. B is a 6. 12. C. Okay. This really needs a pair of parentheses right there. And this really needs its own little box. There we go. All right, let's see what happens now. And we'll see about those negatives. So what goes in this box? Caveman says a B goes in there. So I'm going to put whatever the B says. I'm not going to worry about signs. I'm just going to put it in the box. Okay, B goes here, 6. A goes there, which is 1. C goes here, which is 12. No thinking, just putting the stuff in. We'll worry about thinking later. And so A is 1. Okay, just sticking it in the spot where it goes. And now we're going to take and put this right here in the calculator. What are we not putting in? The square root. Matter of fact, we don't hardly ever use the square root button because only thing it does is give you this crazy estimated decimal, which there's a place for that, but most of the time in Algebra 2, we're not using the square root button. We're going to break it down to exact answers, not approximations, exact answers. Okay, so I'm going to put that into our calculator. So we got open parentheses. Was it 6 for the b? So we put a 6 there. Close parentheses. Squared minus 4. Open parentheses. 1. Close. Open. 12. Close. That's exactly what was underneath the square root. We're not doing any thinking. We're just putting that in there. Hit enter. And now we got negative 12. All right, we're ready to get on back here. So underneath here is negative 12. Okay, so the negative's already there. And then what this turned out to be? Negative 6. All right. And then 2 times 1 is 2. Now, all of this is, again, caveman, low brain level activity. Okay? Very, smart caveman, but the point is not much going on here. Just walk it through the procedures. Don't try to take shortcuts, because that's the whole point. It messes with your signs. Okay, so I'm going to bring over my negative 6. My bar over here, get my 2, my plus or minus. Now, square root of a negative, what's that really? Well, we just take the negative and turn that into I, because that's the square root of negative 1. And then 12, if the negative wasn't there, what would I do? I would say that's the square root of 4 times the square root of 3. That's 12, right? And so there's our negative, the I. 4 times 3 is the 12. Now we just take it one little step at a time. So negative 6 plus or minus I. Whoops, let me back up just a minute, not put that there. Because what's the square root of 4? Plain 2. And I could put it I2, but we usually put it 2I, right? Kind of like 2x. So we could put it in the other order, but this is better. And then what's left over? Square root of 3. And that's all over 2. Okay, now at this point, we can quit? No, we're not done yet. We got to see if we can reduce a fraction, because we always reduce fractions if we can. Now, some people might be tempted just to say these 2's cancel, right? And be done with it, but that would be inaccurate. Okay, remember this is 2 with both of those. So what I'm going to do, and I suggest you do this as well, until you get really used to doing this without rewriting it, is I suggest you rewrite it into 2 separate fractions like that. And now you can see better how to reduce this. Okay, so what's this negative 6 over 2? Well, that's just going to be 3, right? So that's equal to negative 3. Bring down my plus or minus. The 2's reduce, and all I'm left with is I on the square root of 3. And there is my answer. This is the correct answer. Notice how many correct answers did I say? The correct answer. Okay, if you do anything else, it's an estimation or something else. So this is negative 3 plus I on the square root of 3, and negative 3 minus I on the square root of 3. So it's got 2 answers built into it, but this is how you would write it. Okay. Now, one thing I do want to mention, what if that had been a positive 12? Well, the only thing that would have changed is that you wouldn't have had an I on the final answer. Everything else would have been the same. So don't let negative square roots mess with you. Just basically do them like you would normally do. You just got an I right there for imaginary number. So there's second equation. So this one kind of worked out and has an imaginary solution. Okay, the first one was nice and clean. This one's got a little bit more work to it. Let's try one more. Okay, again, this same basic procedure. And I guess I can go ahead and get that cleared out and go put a box right here. Okay, and put my parentheses in here for that box. Okay, So what's our equation here? So the equation is going to be x squared plus 6x equals -9. Okay, so now are we ready to go over here and say that A equals B equals C equals? We ready for that? No, we're not. Because what? It's not equal to 0 yet, is it? So we're going to have to do something to make that happen. So let's add 9, add 9. Okay, and here we go. X squared plus 6x plus 9 equals 0. Now we're ready to go over here and fill these things out. Okay, so A is 1, B is 6, C is 9. Okay, so we're still in caveman mode. So what goes here? B is a 6, B is a 6, A is a 1, and C is 9. Okay, and then what's this guy here? It's an A, that's also a 1. All right, next step, we're going to put this into my calculator. Let's see what happens with that. Okay, what does that turn out to be? Okay, so, all right, get that. So we're going to do open parentheses. We said that B is going to be a 6 closed square minus 4 open. A is a 1. And then the C was positive 9. Oh, if you got -9, it's going to mess the whole thing up, right? So we got to watch out for that sign. Enter 0. Well, that's weird. That is very interesting. Okay, very, very interesting. So 0, all that trouble, and you get 0. So let's go see what happens. Let's plug in our information. All right. So this guy here is going to be what? -6, right? So -6. This is going to be positive or negative. Doesn't really matter. It's going to be 0 in either case. And then 2 times 1 is 2. So what's the square root of 0? 0 plus 0 minus 0. That's silliness. So what that ends up being is just simply -6 over 2 because the 0 went away, didn't it? Then we reduce our fraction, and that just gives me -3, one solution. Now remember from the very beginning, we said those graphs, you could have two real numbers, one real solution, or no reals, but you'd have imaginaries. Well, that's what we've done, okay? And notice what happened. This thing underneath the radical is called the discriminant because it helps you discriminate on what kind of answer you're going to have. So when the discriminant was 0, we had one real solution. And they got these tables and stuff that you could follow. Okay. When we had a negative discriminant like this one, what kind of answers did we have? A double answer here, plus minus, but it was an imaginary, right? Because you can't have square roots of negative. So it's going to automatically jump you into the imaginary world. So when you have the discriminant, the part underneath here is a negative, you're going to have plus or minus an imaginary answer. Okay. And then what happens when it's positive? Like the first example, when the discriminant is positive, what did we have? Two real solutions. Just like the graphs told us was going to happen. But now we've been able to actually find the correct answers using quadratic formula. So that's quadratic formula using the caveman method, as I call it, but basically just walking through some procedures that will help cut out a lot of the primary human error that people have when they do this. Okay. And again, when you're in this part that's highlighted, do it all at once. Don't put it in pieces and hit enter every time. Do the whole thing, just like I did. But if you can get to this point, you can usually have at least fake it or limp over to the other side, especially if you have a multiple choice, okay, kind of situation. But if you can't get to this point, it doesn't matter if you know how to do the rest. You're wrong anyway. So work through those procedures, and hopefully this will be help you get good answers for the one method that works every time, right? The quadratic formula. Thanks for listening. Let me know if you have any questions. Have a good day.